where we position a point and how we describe its position with respect to our familiar two axes, x and the y axis, such that they cross at the origin, as I defined earlier, and they are perpendicular to each other, that is, they are at 90 degrees from each other. So, with this description of what we call the Cartesian plane, we define points. We can define two such points, A and B. Let A be this point, and let B be this point, such that A is defined by x2, y2, and B is defined by x1, y1. So, what do we know right now, just by the description of the 2 points? We know that if we draw perpendiculars like so and like so, we know that this distance is y2, and we know that this distance is y1. Similarly, we know that this distance is x1 and this distance is x2, right there. So we can join this line like so, which represents the distance between A and B. Let us call this AB as the distance. And what about this line right there and this line right there? Let us call this point C. Can we say something about BC? Well, we know that if this is the origin, we know that this distance is x2, and we know that this distance is x1. Therefore, this distance is the difference in the x values. So BC is nothing but delta x, or x2 minus x1. Can we say something about this distance? Similarly, as what we did before, we know that this is y2, this height is y2 all the way from the x-axis to A, and we know that this height where C lies is the same height as where B lies, and that is y1. So the difference of them, that is delta y, is the height of AC. And so we can write AC is delta y, which is represented by y2 minus y1. Thus, we have a triangle A, B, and C such that the height is y2 minus y1 and the base is x2 minus x1, and the right angle is formed at A. By the Pythagoras theorem, we know that the hypotenuse, which is h, which is AB, is related by this relation to the perpendicular and the base. So the height squared, or AB squared, equals this distance squared plus this distance squared, perpendicular squared plus base squared. So the base here is x2 minus x1 squared plus y2 minus y1 squared. Therefore, AB, when we take the root both the sides, we get that equal to x2 minus x1 squared plus y2 minus y1 squared. Now, this gives us the description of the distance between 2 points whose x-coordinates are x2 and x1, and the y-coordinates are y2 and y1. But notice that since we have a square here and a square there as well, we really don't care about the order in which we subtract them. That is to say, if, say, this difference was minus 2, the negative of this distance would have been plus 2. But the square of both the terms is still 4. So we really don't care about the order in which we write these. And we can more or less think of them, these two terms, just as the differences in the x and the y coordinates. So it's much more convenient, and this is what I find, to just express this as delta x squared plus delta y squared. And delta x and delta y are just the differences, and it doesn't really matter in which order we perform the subtraction. And that is the complete description of the distances between point A and point B.